So these notes are called common tangents and tangent circles. So first we're going to look at common tangents. There's two kinds of common tangents. We've got internal common tangents and external common tangents. So internal and external. Now, first I'm going to show you some internal common tangents, and then some external common tangents. So let's say this is the center here, and this is the center here. A common tangent, first of all, means that it's a tangent for both circles. So a tangent for more than one circle. Usually you'll see two circles. So here we've got two circles. I'm going to make an internal tangent. And let's do this in yellow. So now, the way that you know that it's an internal tangent is that it kind of crosses over this middle space in between. And another way to think about it is, if I were to draw a line from the center here to the center here, it would cross over this tangent. So I like to think about it like my circles are in love and they're looking at each other. They're in love, they're in love. Ooh, lots of lovey hearts, they're in love. Well, this internal tangent is breaking their love. It's cutting in between. So the internal cuts the love. All right, so if these circles, these centers are kind of looking at each other and they're in love, this internal tangent will cut through that. Okay, if we were to connect it with a line, it would cut, this yellow tangent would cut through the line that connects those two centers of the circles. The external tangent stays out. Stays out of the love. So again, here's the center of our circles, and the circles are in love. So we've got all these little hearts. They're looking at each other longingly. If we were to connect them, an external tangent would not cross over the line that connects these centers. Okay, it wouldn't cross over those little hearts where they're staring at each other. So an internal will cross over and an external will not. Let's look at an example of how this applies. So let's say we have a circle and with center P. We've got another little circle over here with center Q. And it says RT is a common tangent to circle P and circle Q. RT is a common tangent to circle P and circle Q. Okay, that's how you mark a circle, the little circle sign. So here's R, and here's T, way over here. Let's see if I can get this drawn right. Pretty good. Okay, and it connects the dots here, so we go connect through the center. Now because it's tangent, I know that it makes a 90-degree angle here and a 90-degree angle here, so I'm just going to mark that right away. It says QS equals 7. and S is this point here. So that means this segment is 7. We're calling this X. This is Y. This is 24. And this whole thing is Z. First of all, it wants to know what is PR. So part A, well, or X. X is PR. X equals what? Well, how can we set this up? Well, I know by angle that this big triangle and this little triangle are going to be similar. So I can set up a proportion where I say X over 48. Where did we get 48 from? 24%. X over Z. Oh, because it says RT equals 48. Sorry. I'm missing some information here. This whole thing is 48. Sorry. Okay. So we can say that X over 48, so this little side here, divided by this entire length of the big triangle, and that's going to equal this base here divided by this side here. So we've got X over 48 equals 7 over 24. Sorry, my diagram's a little messy. We cross multiply and solve, and we get that X equals 14. Okay, so that's one example of our common tangents. Next thing is tangent circles. And we have externally tangent and internally tangent circles. The same idea. External and internal. And this is kind of self-explanatory. So here's an externally tangent. Right, they share only one point. And this would be called the point of tangency. And internally tangent, tangent from the inside, they still share one point. But this time the circles are inside each other. Notice these aren't inscribed or concentric, they're internally tangent circles. So here's externally tangent, and here's internally tangent.